All right, let's get right into it. We're going to be talking about a creature that, at first glance just looks like a tiny shrimp, but it's actually one of the most powerful and important forces on planet Earth. Today, we're diving into the incredible story of Antarctic krill. First, just look at this number. Let it sink in. 400 million tons. So what does that represent? Well, that's the estimated total weight, the biomass of this one single species. And to help you wrap your head around that, their total weight is actually greater than the combined weight of all 8 billion humans on this planet. It's just staggering. By that measure, you could argue they are the single most successful animal in the world. So how on earth did this happen? And why does it matter so much? Okay, so here's how we're going to break it all down. First, we'll see how they're the planet's true giants, in a way. Then, we'll get into what makes them different from your average shrimp. We'll look at their role as the ocean's ultimate power lunch, our own surprisingly large appetite for them, and finally, why these amazing creatures are now under some serious pressure. It's pretty simple. Without krill, we would not have the largest animal that has ever lived. A few million years ago, the ancestors of today's great whales, they were only about the size of dolphins. But then, something changed in the oceans, and the krill population just exploded. This superabundant, high-energy food source was the rocket fuel that allowed for the evolution of absolute giants. I mean, the blue whale was literally built by krill. So what exactly are they? Well, biologically, they're crustaceans, yeah, but they're in a whole separate group from true shrimp. And a key difference is something you can actually see. Notice those little feathery things on the side? Those are their gills. And unlike shrimp, who kind of tuck theirs away, a krill's gills are right out there, completely exposed. Funny enough, their name in some languages actually translates to phosphorus shrimp. And no, it's not because they're full of the element phosphorus, it's because of something way, way cooler than that. Yep, they glow. Krill have these amazing light-emitting organs all over their bodies. They get the ingredients they need by eating certain types of algae. And then they use that light for camouflage. By shining light downwards from their bellies, they can perfectly match the faint light filtering down from the surface. And what does that do? It completely cancels out their shadow, making them pretty much invisible to any predators looking up from the darkness below. It's a brilliant survival strategy. And the weird, unique stuff doesn't stop there. Get this. The Antarctic krill genome, which we only just fully mapped out in 2023, is 16 times larger than the human genome. Absolutely massive. So, why is it so ridiculously big? Well, what science has found is that over 90% of it is just junk, repetitive, non-coding DNA. It's super inefficient. And the leading theory is that for millions of years, their food was just so abundant that there was zero evolutionary pressure to be efficient. This giant genome might just be a surplus phenomenon. Basically, it's a side effect of being too successful and way too well fed for a very, very long time. Now let's talk a little more about that food. In most ocean food webs, energy has to take a bunch of steps to get from the bottom to the top. You have microscopic plants, which get eaten by tiny zooplankton, which get eaten by small shrimp, which then get eaten by small fish. You get the idea. It's a long chain. But krill are special. They skip the line entirely. Even though they can be a couple of inches long, they can directly filter those microscopic phytoplankton right out of the water. And this is the whole key. They create this incredibly efficient energy shortcut, packing the fuel from millions of tiny plants into one perfect bite-sized meal for huge predators. And when I say huge, I mean it. When a blue whale takes a single massive gulp of seawater, it can filter out around 500 kilograms of krill in one go. That's like eating 1,000 hamburgers at once. Without that incredible density of food, a whale could never, ever get enough calories to survive. And this really shows why they're the keystone of the entire Antarctic ecosystem. I mean, the diets of whales, crab-eater seals, and Adelie penguins are made up of over 90% krill. They are the engine that runs the whole show. And on top of that, they're these unsung climate heroes. Their molted shells and their waste sink really fast, carrying huge amounts of carbon down into the deep sea, where it gets locked away for centuries. So, where do we humans fit into this picture? Well, we've been fishing for krill for a while. There was this big boom back in the 80s, mostly led by the Soviet Union, trying to turn it into a food paste. After the USSR collapsed, things quieted down for a bit. But since 2010, there's been this huge resurgence, and catches are now hitting all-time highs. So what's driving this new boom? You're probably thinking of krill oil supplements, right? And yeah, they're part of it. That's that smaller slice of the pie. But the real driver, the vast majority of the catch, is actually for fish farming. It gets ground up into feed for farmed fish, especially salmon, because it gives their meat that pinkish-orange color people expect to see. And knowing that it's all about salmon farming, it's really no surprise who's leading the pack here. Norway, a giant in aquaculture, is responsible for about 2/3 of the entire Antarctic krill catch, and they're followed by growing fishing fleets from China and South Korea. Now, this whole fishery is managed by an international commission, and they set a quota every year. Right now, it's 620,000 tons, but when you put that next to the total biomass, all 400 million tons of krill out there, the catch seems like a tiny, tiny drop in the ocean. Which, of course, leads to the big question. If we're taking less than 0.2% of the total, what's the big deal? Sounds totally sustainable, doesn't it? Well, the problem isn't the total number. It's where the fishing is happening. You see, the fishing fleets all gather in a few very specific, easily accessible spots, which just so happen to be the exact same critical feeding grounds that penguins, seals, and whales need to survive. So while the global number is small, the local competition for food can get incredibly intense. And this direct competition is happening at the same time as even bigger threats are closing in. Climate change is melting the sea ice that young krill desperately need for food and shelter. And at the same time, all the CO2 we're putting into the atmosphere is making the ocean more acidic, which could make it harder for them to build their shells and might even stop their eggs from hatching properly. And that really brings us to the final critical thought here. The story of krill really is the story of the Antarctic. The biggest animals this planet has ever seen only exist because of this one creature's incredible success. But now, as this absolute keystone of an entire ecosystem faces pressure from all sides, you really have to wonder, if the ocean's giants were born from krill, could they also disappear with them?